quadratic functions in factored form. More specifically, moving on to applications of quadratic functions in factored form. We need to review a few things first. We need to think about what does it mean when we solve a quadratic equation. It means we're finding the x-intercepts, or the roots, or the zeros, or we could call it the point of intersection of the x-axis with the function. And sometimes, when we're asked to solve a quadratic function, it doesn't always make sense. For instance, if we look at solve a quadratic equation. If we look at the quadratic equation, 0 equals x squared plus 1, we've learned we can solve a quadratic equation by factoring. Now, there were two terms. First thing I look for is a common factor, and obviously there isn't one. And then since there are two terms, I look for a difference of squares. I do see two perfect squares, but they're both positive, so I can't factor that. So what's another alternative? I could try and solve it like we did in the first unit by isolating for x. So if I move the 1 to the other side, I end up with negative 1 equals x squared. Well, that doesn't even make sense because we can't take the square root of a negative number, so we cannot solve this, and we know that this equation has no real roots. Other questions we've looked at, if we look at this equation, writing the equation of a quadratic function in factored form, where the roots are x equals negative 2 and x equals 6, and it passes through the point 37, this is no different than the equations we found in the first unit. If we look at this, we know the roots are negative 2 and 6. Well, roots means use factored form. And since r is negative 2 and x would be 6 in this situation, we can substitute them into the equation as x subtract negative 2 and x subtract 6, which simplifies to x plus 2 times x minus 6. Now you'll notice that I've got an a value in front. I always have to think about the value of a because I don't know if I have a vertical stretch. Am I expanding? Am I compressing? Or is it just the same, or is it congruent to the parent function y equals x squared? Since it goes through the point 37, I can substitute that into the equation to solve for the value of a, or the vertical stretch factor. So once I use my good friend BEDMath, this will simplify to 7's negative 15a, and I divide both sides through by negative 15, and I discover that I in fact have a vertical compression by a factor of 7/15 and a reflection in the x-axis. But it didn't ask me for that. That's just an interesting piece of information for review. So I know the equation is f at x equals negative 7 over 15 times x plus 2 times x minus 6. There was a unique answer to that question. We're going to look at some questions where there aren't unique answers, and we're going to look at a quadratic equation in factored form with some roots that you're going to see on the next screen. And I want you to write a family of quadratic equations and the family of quadratic functions. So we're going to differentiate again between a function and an equation. So if I have two roots that are negative 1 and 4, that tells me x is negative 1 and x is 4. And I can move the constants to the other side, so I'll get x plus 1 is 0 and x minus 4 is 0. And if this is a quadratic equation, it would have the factors x plus 1 and x minus 4. So one quadratic equation would be x plus 1 times x minus 4 equals 0. Now it asks for a family of quadratic equations. Well, that's a little bit different because that's any possible solution. There's an infinite number of quadratic equations that would have that would have those roots. And that would be indicated by putting a vertical stretch factor here in front. So the minute I put an a value in front, I have created, oh, I lost some of my answer. The minute I put an a value in front, I've shown you the family of quadratic equations. Okay. So a can take on any value, and there are an infinite number of solutions. Sorry about that. And if I wanted the family of quadratic functions, the only thing that's going to be different is, remember, a quadratic equation had the one variable. We could set it equal to 0. The quadratic function, and you can't really see this that well, the quadratic function has the f at x. So there are, in fact, two variables. The f at x equals a times x plus 1 times x minus 4. our roots are not nice numbers, so they're fractions, they're rationals, it's not really that much different to find a possible quadratic equation or to state the family of quadratic equations or to state the family of quadratic functions. So the first thing I can do for my roots, x is 2/3 and x is -1/2. For x equals 2/3, I can multiply both sides by 3 to eliminate the rational. And for x equals -1/2, I'm also going to multiply, but I'm going to multiply by 2. Then I need to move the constants to the left side of the equation. And I end up with 3x minus 2 equals 0 and 2x plus 1. And just like we did with the last equation, we multiply the two factors, set it equal to 0, and I have one quadratic equation with the given roots. If I want the family of quadratic equations, I'm just going to put an a in front. If I want a family of quadratic functions, I am just going to switch it up and put it as f at x equals a times 3x minus 2 times 2x plus 1. And before you come to class tomorrow, there's always lots of fun. Exercise 8 in your workbook, pages 14 to 15, questions 1 to 3. Have a good night.